three resistors of 2 ohm, 3 ohm and 6 ohm are connected in series and also in parallel. We need to draw the arrangements of the resistors in series, also in parallel, and also find the equivalent resistance of series and parallel arrangement. This question carries 3 marks. 1.5 mark for the series part and 1.5 mark for the parallel part. In a series connection, resistors are connected one after another in a single path. These dots are the terminal points of the circuits. In a circuit diagram, dots represent the connection points where the wires meet. In series connection, this dot indicates that where the current enters and this dot indicates that where the current leaves. When two resistors are connected in series, the formula for finding the equivalent resistance is Rs is equal to R1 plus R2. When three resistors are connected in series, equivalent resistance Rs is equal to R1 plus R2 plus R3. Here 2 ohm, 3 ohm and 6 ohm, three resistors are connected in series. So we can substitute the values in the above formula. It is equal to 2 plus 3 plus 6. That's equal to 11 ohm. Draw three separate branches, each containing one resistor. All branches start and end at common points. In a circuit diagram, these two dots represent the connection points where the wires meet. In parallel connection, all starting ends must join at the same point. Also, all ending ends must join at the same point. This diagram carries half mark. When two resistors are connected in parallel, the formula for finding equivalent resistance is 1 by Rp is equal to 1 by R1 plus 1 by R2. Here, three resistors are connected in parallel. So, equivalent resistance 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the values. It is equal to 1 by 2 plus 1 by 3 plus 1 by 6. It is equal to 3 plus 2 plus 1 by 6 equal to 6 by 6. That is also equal to 1 by 1. 1 by Rp is equal to 1 by 1. So Rp is equal to reciprocal of 1 by 1, that is 1 ohm. When resistors are connected in series, the total resistance, that is equivalent resistance, is always greater than the largest resistor. Here the largest resistor is 6 ohm and the equivalent resistance we obtained is 11 ohm, which is greater than 6 ohm. When resistors are connected in parallel, the total resistance is always less than the smallest resistor. Here the smallest resistor is 2 ohm and the equivalent resistance we obtained is 1 ohm, which is less than 2 ohm. Always draw a box around the equation. When two resistors are connected in series, the formula for finding equivalent resistance is Rs is equal to R1 plus R2. Draw a box around this formula. Draw a single underline for each intermediate answer in this way. Draw a double underline for the final answer. In final answer, we should draw a double underline like this. And also don't forget to write the SI units in the answers. Here SI units are ohm. So 6 ohm, 8 ohm, like that. Now we will learn how to solve a circuit that contains both series and parallel connections. Two resistors of 10 ohm and 15 ohm are connected in parallel. Another two resistors of 60 ohm and 40 ohm are also connected in parallel. These two parallel combinations are connected in series. The circuit is connected to a 15-volt battery. We need to find the total resistance, that is equivalent resistance of the circuit, the total current drawn from the circuit. Also, the potential difference across the parallel combination of 10 ohm and 15 ohm resistors. This question carries 3 marks, 1 mark for each sub-question. First, we find the equivalent resistance of this parallel connection. To find equivalent resistance of parallel combination, we use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2. Let us consider the equivalent resistance of 10 ohm and 15 ohm resistors as Rp1. So 1 by Rp1 is equal to 1 by 10 plus 1 by 15 after substituting the values. It is equal to 3 plus 2 by 30. 30 is the LCM. It is also equal to 5 by 30, that is 1 by 6. So 1 by Rp1 is equal to 1 by 6. So Rp1 is equal to 6 ohm. Next we find the equivalent resistance of this parallel connection. Let's consider the equivalent resistance of 60 ohm and 40 ohm resistors as Rp2. So 1 by Rp2 is equal to 1 by 60 plus 1 by 40. That's equal to 2 plus 3 by 120. 120 is the LCM. That's also equal to 5 by 120, which is equal to 1 by 24. So 1 by 24 is 1 by Rp2. So Rp2 is equal to 24 ohm. Now both parallel groups are connected in series. Here the equivalent resistance is 6 ohm and here equivalent resistance is 24 ohm. Since these two are connected in series, we can now find their combined equivalent resistance. To find the equivalent resistance in series connection, we know the formula Rs is equal to Rp1 plus Rp2. That is equal to 6 plus 24 after substituting the values. Then we get it is 30 ohm. Now let's move to question B, finding the total current drawn from the source. Here we have a 15-volt battery. We have already calculated the total resistance of the circuit as 30 ohm. So using Ohm's law, V is equal to IR, we can find the current. I is equal to V by R. After substituting the values, we will get 15 by 30. That's equal to 0.5 ampere. In question C, we need to find the potential difference across this parallel connection. 15 volt is the potential difference of this whole circuit. According to Ohm's law, V is equal to IR. We have already calculated the equivalent resistance in question A, and in question B we found the current drawn from the circuit. Equivalent resistance of 10 ohm and 15 ohm we got it 6 ohm and current we got 0.5 ampere. After substituting the values we will get 3 volt. So 3 volt is the potential difference across between the resistors 10 ohm and 15 ohm. Four identical resistors of 12 ohm each are connected in series to form a square ABCD. We need to find the resistance of the network between two points 1 and 2 located between A and B. Options are given 48 ohm, 36 ohm, 9 ohm and 6 ohm. This is an MCQ and carries 1 mark. Points 1 and 2 are placed in between resistor A and B. So the current can flow from point 1 to point 2 through two different paths. This is first path and this is second path. The resistance of first path is 12 ohm. We want to find the equivalent resistance of the second path. These three resistors are connected in series. In series combination, equivalent resistance is Rs is equal to R1 plus R2 plus R3. After substituting the values, it is equal to 12 plus 12 plus 12. That is also equal to 36 ohm. We need to find the total resistance of this network. First path and second path are connected in parallel between points 1 and 2. Let's consider the resistance of first path is R and second path is Rs. So 1 by Rp is equal to 1 by R plus 1 by Rs. It is equal to 1 by 12 plus 1 by 36 after substituting the values. LCM is 36, so it is also equal to 3 plus 1 by 36 equal to 4 by 36 is equal to 1 by 9. 1 by Rp is equal to 1 by 9. So Rp is equal to 9 ohm. So correct answer is option C, that is 9 ohm. A similar type of question was asked in 2025 board exam as a 2-mark question. The question is 4 resistors, each of resistors 2 ohm are joined end to end to form a square ABCD. Find the equivalent resistance of this network between the two ends A and B. Here the resistance of first path is 2 ohm. Now we can find out the equivalent resistance of second path. Rs is equal to R1 plus R2 plus R3. After substituting the values, it is equal to 2 plus 2 plus 2. Then after calculation, we will get 6 ohm. Now we can find the total resistance of this circuit. Here, this resistance and equivalent resistance of these three are connected in parallel. The resistance between A and B we can consider as same as R, and the resistance between A and B of this path is considered as Rs. So 1 by Rp is equal to 1 by R plus 1 by Rs. Substitute the values. It is equal to 1 by 2 plus 1 by 6. It is also equal to 1 plus 3 by 6. 6 is the LCM. It is equal to 4 by 6. That is equal to 2 by 3. 1 by Rp is equal to 2 by 3. So Rp is 3 by 2. 3 by 2 is equal to 1.5 ohm.